Welcome to Summarize Science. When you perform a simple task like picking up an egg, you use more than just your eyes. You use your sense of touch to know how firmly to grip it and your spatial awareness to move it without hitting anything. For robots to become truly useful in our world, they need these same abilities. Most current AI models for robots primarily rely on 2D vision and language instructions, as you can see in the top diagram. This is like trying to work with one eye closed. You lack depth perception and a sense of touch. But what if a robot could see in 3D, feel what it's touching, and understand language all at once? That's the idea behind a new model developed by researchers called MLA, or Multisensory Language-Action model. As shown in this bottom diagram, MLA integrates multiple streams of information, standard 2D images, 3D point clouds for spatial awareness, and even tactile signals from sensors on its gripper. The way it combines this information is incredibly clever. Instead of having separate processing units for each sense, it repurposes its core AI brain, a large language model, to understand all these inputs in a unified way. It aligns the data by mapping where the 3D points and touch sensations occur on the 2D image, creating a rich, interconnected understanding of the scene. But here's the most futuristic part. MLA is trained to predict the future. It doesn't just react to what's happening now, it generates what the future image, 3D scene, and tactile feedback will be after its next move. This imagination gives it a deep understanding of physical dynamics, helping it plan actions more effectively. So, does it actually work? The results are impressive. In a series of complex, real-world tasks like wiping a whiteboard or carefully placing an egg on bread, MLA significantly outperformed previous state-of-the-art models. The performance boost was huge, beating other vision-based models by 12% and 3D-based models by 24% on average in these real-world tests. It also excelled in a wide range of simulated tasks, achieving an 81% average success rate, as shown in this table. Crucially, MLA is also better at generalizing. When faced with unseen objects or cluttered, unfamiliar backgrounds, it maintained a much higher success rate than older models. This ability to adapt is key for robots operating in unpredictable human environments. So, let's recap. The MLA model gives robots a more human-like perception by combining 2D vision, 3D spatial data, and a sense of touch. It uniquely uses a single powerful AI to understand these senses together and enhances its planning by predicting the future state of the world. This leads to a robot that is drastically better at performing complex, contact-rich manipulation tasks. The implications for the future are enormous. This research is a major step towards creating more competent and reliable robots that can assist us in our homes, factories, and maybe even in delicate surgical procedures. Thanks for watching Summarize Science, and we'll see you next time.